This is Greg Troutwine with Marine Technology TV, and we're very pleased to be joined again by Bruce Appelgate, the Associate Director and Head of Ship Operations at the Scripps Institution of Oceanography, to discuss the recent news that the UC San Diego received $35 million to design and build a new hydrogen hybrid propulsion research vessel. Bruce, first and foremost, welcome back to Marine Technology TV. It's always good to speak to you.
Thanks, Greg. Yeah, it's great to be here.
You know, Bruce, obviously, the recent news on the hydrogen hybrid propulsion research vessel made quite a stir. Can you give us a bit of background on how all this came about?
We've been working on this kind of a project since about 2014 now, when we initially partnered with Sandia Laboratories to look at the feasibility of using hydrogen propulsion on a research vessel. So we finished a feasibility study that found that could be done using commercially available equipment right now. And then we had another question: was what about a hybrid approach to this? It seems to be sensible from a risk standpoint to have the ability to fall back on diesel if we needed to, but still be able to transition to hydrogen. So we did a feasibility study for that, and that came out. And then on the basis of the success of that study, we began talking to people about, let's make it real.
So I know we're still early in the process, but can you give us a timeline? Where are we today?
Well, we're still celebrating the announcement from the state of California, which we're very grateful for, and putting together a management team. And so that's underway right now here at Scripps. We expect that this is probably going to be on the order of a 4-year project. So with any luck, 4 years from now, we'll be putting something into the water.
Okay. Do you have an ETA on when to get a bid package out to the shipyards, or is it still too early to discuss that?
Still too early, I think. So we're going to take a really close look at the engineering and have a detailed design ready to go, so that when we do go out for bids, we'll have something complete and ready to build.
So what specifically then, Bruce, are the next steps to get this project in motion? Can you discuss any hurdles, financial, technical, that must be overcome before this ship becomes a reality?
Well, our objective with this vessel is to build an uncompromising, very capable research vessel. An important step in the beginning step is meeting with a science advisory board, who is going to be able to provide input from the very beginning. So when we design the vessel, it's optimized for the work that we want it to do. So internally, that's an important first step, as important as putting the management team together. And that's underway now. And so that's sort of the first part of the technical challenge that we've got. And then based on the feasibility studies that we've done, we know that the parts can all come together. But I think as we come around to working on the detailed design, some of the technical challenges involved with things like bunkering and the gas systems on the vessel, there's going to be details that will still need to get sorted out. A lot of this hasn't been done at this scale in the marine industry yet. So there's a lot of learning to do, I'm sure.
Why was it decided, or why was it deemed important at this time to steer away from a strictly diesel option?
Right. Well, it's part of the University of California's plan to become carbon neutral by 2025. And a huge part of our diesel consumption in the University of California is our research vessels. So the emissions impacts of ships are tremendous. We're very interested in reducing our criteria pollutants from our ships, because criteria pollutants harm human health, and that's bad. We're very interested in reducing and eliminating CO2 pollution from our ships, for the obvious reasons that it's warming our planet, and that's something that we want to support. So from an emissions standpoint, hydrogen was important to us. We looked at several options. Our most recent feasibility study looked at a battery hybrid system. Basically, what we wanted to do with the last study was we took a common hull and we wanted to put 4 different kinds of propulsion systems into it. So keeping everything constant except those propulsion systems. And looking at the pros and cons of all 4 of those, we get the best range, and we meet our science mission the best with our emissions target with a hydrogen hybrid.
Bruce, as you know better than I, incorporating leading edge technology always comes with risk. What do you see as the chief challenges, and what are you and your partners doing to mitigate that risk?
Well, the great challenge really is doing something that's never been done at this scale before with technology that we think can work, that, you know, based on the feasibility studies we've done. But yeah, we are on the bleeding edge on this one. And so that's why I think having a really solid foundation in a detailed design and the engineering in advance, that's the approach that we're going to take to try to retire some of that kind of risk as early as we can. Look at all how things go together, and do that in the engineering before we start cutting steel. We're going to learn a lot, but it's kind of what we do here at Scripps. I think, you know, we are very interested in exploring new technologies and new approaches, and frankly, this is the sort of thing that can be transformation in the maritime industry, and that's why it's so important that it does get done.
I kind of want to shift gears here from just the pure technical aspects of the ship to the capabilities. Can you give us a brief on the ocean research technologies we might expect to find on board this ship, with impacts or with insights on how this new vessel will effectively impact your very important studies? Sure.
The ship that we're envisioning is a replacement for our little workhorse vessel, Robert Gordon Sproul. It's a 125-foot regional research vessel. And the target kind of work for this vessel is going to be California coastal and offshore work. So we'll range up 250 miles or so with a vessel like this, with a duration of a couple of weeks is what we're targeting. And the ships that we operate at Scripps are general purpose shared use vessels. So they need to be jacks of all trades. So we're going to be able to do everything from acoustics and seabed mapping to midwater imaging to surface observations, and then classic things, of course, like CTD profiling and water sampling and net tows. So it's really going to be a very broadly capable vessel. So our vision is to have a suite of sensors on board, from mapping sonars to midwater imaging sonars, ADCPs, but also all the overboard handling equipment that comes with that, you know, the kind of work that we're envisioning for doing net tows and winches, and yeah, the whole shooting match. Okay, well, Bruce, again, thank you for your time. We look forward to working with you and your team as this project progresses. And thank you very much. Good to be here.